Well, now we're going to start looking at radical functions, and specifically here for the next few episodes, we're going to be focusing on square root functions because we're also looking at inverse functions. And as you think through it, a square root function is the inverse of a quadratic function. In other words, something squared and something the square root of, those two are inverses of each other. Now, with the quadratic function, when we're talking about domain and range in its parent form, the domain is all real numbers. There's really nothing to restrict the domain. But we do see some restrictions in the range. And that, again, if I just got if f of x is equal to x squared, my range is going to be greater than or equal to 0, because even if I try to square a negative number, it's still going to be a positive number. So everything's in the upper half of the coordinate plane, if you will. But with a square root function, we do see that we can experience a restriction to our domain. And that is, for any real numbers, we cannot take the square root of a negative number. So here we've got a couple of square root functions. We're asked to identify the domain and the range. And so what we want to do is we want to take what's underneath the root, or what's underneath the radical, and we want to set it up something like this, where let's say we got x minus 3 must be greater than or equal to 0. Because I can't take square root of a negative number. I can't have something that's negative in there. And so let's add 3 to both sides, and we would see that x must be greater than or equal to 3. Think, for instance, what if x was 2? Well, 2 minus 3 is negative 1. We're trying to take square root of negative 1. It doesn't work. So my domain in this case, the domain is x such that x is greater than or equal to 3. And my range, I don't really have anything that changes the range from its inverse, the quadratic. So it's going to have to be, my range then is y such that y is greater than or equal to 0. Now, that's not always going to be the case for the range, as we're getting ready to see here in the next example. So here we've got f of x equals x, the square root of x plus 6, and then plus 2. Well, that plus 2 is a vertical shift, and that's going to change the range from greater than or equal to 0 to greater than or equal to positive 2. But let's go ahead and focus on the domain. Again, I'm going to work with what's inside the radical, the square root, and we're going to set this up as x plus 6 must be greater than or equal to 0. And then we're going to subtract 6 from both sides, and once we do, we discover that x must be greater than or equal to negative 6. And so again, let's say x is negative 5, greater than or equal to negative 6. Well, negative 5 plus 6 is 1. Square root of 1 is 1. So what's underneath the square root symbol, what's underneath the radical, helps us define any restrictions to the domain. And so in this case, the domain is equal to x such that x is greater than or equal to negative 6. And again, this positive 2 outside the radical gives us a vertical shift, which is going to change the range to y such that y is greater than or equal to 2. Now, in our next episode here, our next video, we're going to take a look at the graphs of these, and we'll see how that does with various transformations. But there we go, square root functions. A little later on, we'll look at some square root inequalities too, and that will be fun.